Good morning, everyone. Thank you for joining us today. Allow me to introduce myself. My name is Georgie Gould from Global Community Resourcing. I am pleased to be the moderator for today's webinar, the focus of which is how virtual reality is helping older people understand and improve their driving competence in a low-risk environment. Our webinar today is facilitated by Global Community Resourcing for the Community Care Smart Assistive Technology Collaborative. Global Community Resourcing has extensive international linkages, and we have been fortunate enough to work on many international projects. If you have joined us for previous webinars, you will know that they are designed from feedback and requests we receive through the collaborative. The focus of our webinars is to bring together local, national, and international perspectives in research and development, as well as deployment in smart assistive technologies in the community care sector. Just a reminder that if you haven't formally registered for the collaborative site, it is accessible to all and free to register. Visit satcommunity.com.au to register today. Please note that Global Community Resourcing are not promoting or endorsing any particular product, research, identity, or organisation. The purpose of our webinars is to serve and to inform viewers of various smart assistive technologies currently in development or deployment. We welcome questions, but I will let you know that all microphones have been muted. This is in the interest of recording. Your questions can be added to the question panel on the dashboard on the right of your screen. There will be an opportunity for your questions to be answered at the end of the session. At previous sessions, we have been inundated with questions, so the earlier you post your questions, the more questions we can respond to. For those who have not used GoToWebinar platform before, your control panel will be on the right of your screen. To change the placement of the control panel, drag the top of the panel or click the box button on the top right of the panel or the arrows. To ask a question or contribute to the chat, click Chat and type your message. In this webinar, Sue and Michael will provide a range of insights from their work on the Department of Health's Dementia and Aged Care Services DACS-funded project on driving simulates for older people. Sue Thomson is the CEO and Company Secretary at Mclean Care and has over 20 years experience in the community care and aged care sectors, working in a variety of leadership roles in Australia. Sue considers the most important aspect of her work to be giving a voice to older people and service providers in rural and remote Australia that otherwise would not have a voice. Michael is an industry research fellow within the School of Engineering at Deakin University. Michael works for the Centre of Advanced Design and Engineering Training Virtual Reality Laboratory, where Michael and the team focus both fundamental and applied research into VR and human-computer interactions. Welcome, Sue and Michael. Take it away.
Good morning, everybody, and thanks for tuning in this morning. So Michael and I will be talking to you today about Hector VR, Australia's first driving simulator. I'll provide you with some background information, and Michael will talk to you more about the development and research design of this fantastic project. Firstly, a little bit about who we are. Mclean Care is a not-for-profit community-based organisation, and our heartland is in regional and rural farming communities. Our organisation was founded on a bequest of Hector Mclean, and clearly that's the emphasis of the name Hector. We operate home and community care services for older people and people with disabilities in residential environments and in independent living as well. So we service across 185,000 square kilometres in the New England and northwest of New South Wales and on the Darling Downs of Queensland. All in all, it's an area that's 6 times the size of Belgium and 3 times almost the size of Tasmania. So quite a large service area for us. Our Deakin partners, our key people in this project have been Ben Horan and of course Michael. Ben is an associate professor and Michael is an industry research fellow with the School of Engineering. Ben is the director of the Centre for Advanced Design and Engineering Training, which is the cadet unit for the Virtual Reality Lab, where the team, including Michael, focus on both fundamental and applied research in VR, haptics, and human-computer interaction paradigms. The team's technical expertise lies in mechatronics, robotics, virtual reality, and soft computing. Their partners include Melbourne Water, ANZ, IP Australia, General Motors, and the National Wool Museum. Alicia Eugene has also been a business partner of Mclean Care and has expertly managed this project for both Mclean Care and Deakin University. Alicia is a Prince 2 project management practitioner with a very strong background in research and development. So we know that there's huge driving challenges for the older population, and we know that over the last 50 years, the number of Australians over the age of 65 has increased by 300% to 3.4 million, and those over 85 years by 900% to almost 500,000 people. And the ABS predicts that by 2064, there will be more than 9 million Australians aged over 65 and almost 2 million Australians aged 85 years and older. According to the World Health Organization, the world's population aged older than 60 years is estimated to grow to about 2 billion by 2050. We've heard these statistics many, many times over, but perhaps we haven't actually heard them in the context of what that means for older drivers. So research is already showing us that risk increases for older drivers and that older drivers have the highest risk of losing their lives in a motor vehicle accident. And there are a number of factors that contribute to this that relate to changes in sensory and perceptual processing, attention, and even cognitive ability. As the Australian population in Australia grows, and as the morbidity rates for this population reduce, as they are predicted to do, we will inevitably see more older drivers on the road. However, the sensory and perceptual processing, and attention capabilities and cognitive ability is potentially unlikely to change for older people at the same rate as those morbidity changes. So essentially, we possibly will have more older drivers on the road with those sensory and perceptual processing issues. Clearly, this equates to a possible increase in risk. There is a public discussion at the moment that there should be or could be a need to remove or restrict licenses at specific ages, or even for those that have specific diagnosis. We need not forget that the dominant narrative today is one that focuses on respect for older Australians, and I'm not sure that those two suggestions reflect that narrative. But there are other ways. So whilst we know that driving capacity declines with age, we also know that many older people are capable of driving safely well into old age. Recognising how critical a licence is to independence and to quality of life is central. So mobility is a key independence factor. It allows access to day-to-day activities, medical appointments, and social engagement. Research confirms, however, that driving cessation is associated with a number of negative outcomes, such as declining quality of life and general health, depression, social isolation, and even premature entry to residential care. So how do we strike a balance between safety, self-determination, and quality of life? I want you all to imagine for a moment that you are 78 years old, you live on a 10,000 acre cattle property, 2.5 hours away from your nearest supermarket, your nearest hospital, and your nearest bank. Your driveway alone is 10 kilometres long. So how do you age in place if there is no public transport? No taxis, no Uber, no Coles or Woolies shopping delivery, and your closest family resides 100 or more kilometres away, thousands of kilometres away in Sydney. So how do you get to do your shopping? How do you get to medical appointments? How do you stay connected with your community and your friends? So living and working in the heartland of regional and rural New South Wales and Queensland, our team here at Mclean Care are acutely aware of the impact that having no licence has on an older person when they live in rural communities, especially those that don't reside in any townships. We wondered, how can we support older people to make dignified and objective decisions about driving, and how can we help them maintain and improve their driving skills so they can keep their licences for longer? And how can we do this in a low-risk environment that doesn't pose a threat to their safety or the safety of other road users? So here at Mclean Care, I'm really proud to say our team are a true group of blue sky thinkers. And so they find opportunities, they seize them, and they just get on with doing it. And we've experimented here in our residential services with virtual reality and have been astounded by how much our residents have enjoyed virtual reality and how they fully immerse themselves in it. So we realised that our answer lay with virtual reality. So when the Dementia and Aged Care Seed funding round was announced in 2017, we were quick to submit an application for a virtual driving simulator, an Australian first, that would harness virtual reality technology and a simulator to be designed especially with and for older drivers. We were successful, and our project was only one of 8 projects that were funded nationally. The team from the Cadet Lab in the School of Engineering at Deakin were selected as our preferred partner. They offered subject matter expertise that couldn't be matched by other proposed partners, a fantastic VR lab that is truly amazing, and importantly, researchers with real life experience committed to working with Mclean Care to deliver better outcomes for older people. So together we have developed a unique partnership bringing together Mclean Care's aged care and project management expertise and Deakin's VR technical expertise, all for the benefit of older drivers. So Michael is now going to take you through some of the next phases of the development of Hector VR.
Fantastic, thanks for that, Sue. The next part of the presentation is going to talk of a high-level overview of the development of the project. So Mclean Care came to us in late 2017 with the idea of using virtual reality with a real physical car, with the objective to assist older drivers as they age with their licensing, making decisions about their licensing, etc. So I just wanted to start with basically going over some of the project objectives. So firstly, the idea was to look at the possibility of improving driving competencies for older drivers. So the idea of basically practicing certain tasks in a virtual environment repetitively, and then seeing if they can improve their driving skills. The second one was to enable old drivers to safely and easy access to their measures in driving competency. So as you'll find out a bit later on, they could be things such as reaction times and understanding the latest road rules and etc. And then the assessments can be given to them, the elder driver, to make informed decisions about their license, whether they want to have restrictions or they're looking to relinquish, and make that decision more dignified than someone telling them otherwise that they can't drive. So that was a very main objective for the project. The next one was to provide users with the opportunity to have that have had their licenses relinquished, such as people that might have dementia, to just re-experience that driving again through virtual reality. So that was more from an enjoyment factor than anything else. And then obviously one of the main key drivers is to improve overall road safety. So as Sue said earlier on, we're trying to strike a balance between those drivers on the road that may be at high risk to the general public, and then a vast majority of drivers that are of older age that are still quite capable to drive. We don't want them to relinquish their license early and go into the options of not being able to get around with public transport, or being able to make doctor's appointments or do their regular shopping, etc. So those were the project objectives. If we move on to the next slide. So the approach we took once we got the project was a approach called action-based research. And basically what that means, it's a reiterative reiterative process in which we go through several steps over and over again in order to continually improve the research and development of a project. So action-based research has 4 main steps. So the first step in the initial stage at the beginning of the project is to plan it out. So what you would generally do is go look at the literature, go look at what other people have developed, and then create a plan based on those outcomes for a project to go forward. And then from there, from that initial plan, then you act it out. You obviously go through the development phases, etc., like that. And so once you've done your first planning and action, you can then observe what the outcomes are, and you generally do that through evaluation. So in development, you don't want to do a self-assessment of what you're developing, because then it becomes of no use to the end user. So in this case, we want the end user, after we do a development cycle, to go and have an actual try of the, in this case, the VR simulator, and then for them to provide some feedback that we can go away with and reflect upon. And that reflection is that last step. So after the evaluation, we look at their feedback. In this case, it was through surveys, and they'll highlight key parts of the project we need to improve, or things that we've missed out that could be good to include, etc. And we then start the process again. So we go back to the planning phase. And in the Hector VR project, we did this for 3 times. So the 3 development cycles we had was an alpha, a beta, and then the final release. So at each cycle, we had users evaluate the actual development, and then we went away, reflected, and built upon that. So it just means that the end user is part of the process of the development. So if we can go through to the next slide. Okay, so this gives us a bit of an overview of the timeline that the Hector VR project had. So you can see back in February 2018 is when we acquired the actual vehicle. So the physical vehicle was a Holden Captiva. And then between February and April, we had a panel beating shop basically modify that car, so cut the car in half so that it could fit into the room of interest, and then make sure that it was all cut and cleaned and finished, etc., ready for us to develop upon. And so during that phase, that initial phase, while it was being at the panel shop being modified, that's when the ethics and the project planning started. So with any form of evaluations or any data acquisition that you want to use in research, you want to make publications about, you have to go through an ethics approval process. And what that just entails is that, you know, who's your audience? Are the audience of special need? And if so, you know, need to take special considerations, or are there certain hazardous aspects about the project in which you need to take careful planning about? So the ethics approval process validate that the data acquisition is of some standard, and therefore it can be published with a certain level of confidence. So in our case, that it was a fairly straightforward process, but you can imagine in the medical industry it can be quite different for medications, etc. So once we had the modified car back at Deakin University, we started the alpha development stage, which I think was about 2.5 months. And just towards the end of that stage, we also conducted a VR experiencing day. And this was an important part of the project as well. What it meant is that we were able to give the target participants some experience about virtual reality, about the technology, before they undertook any evaluation throughout the development cycles. And what that means is before they actually use the driving simulator, they've got some idea of the technology being used, and they're not so overwhelmed when they first come to use a fairly new product. As Sue suggested before, this is, we believe, the first in Australia of a mixed reality driving simulator. And what that means is mixed reality meaning using a real physical car that's then connected up to the virtual environment. and driving a virtual vehicle. So it's a combination of the real world, interfacing with the real world, and then also with a virtual world as well. So at the end of the alpha development stage and after the VR experience day, we started the alpha evaluations, which were conducted in July, and they went for about a week. And for that, I'll go through the numbers a bit later on, but we grab the evaluation and we do that action-based research, reflect on the results, and go back and plan and redevelop again. And that redevelopment was the beta phase for about 2 months. Again, another evaluation in September, and the cycle was repeated for the final development, which was released in mid-November. So if we can move on to the next slide. Okay, so the alpha development obviously was the first development stage, and the main challenges we had at the university was to take this physical car and then create a physical interface to the real steering wheel, the brakes, the accelerator, the indicator, the shifter, and all the other instruments and sensors that are used in the actual vehicle. So that was just a matter of connecting to those devices within the vehicle and then bringing that information in and out of the virtual environment. The second part was to then build the virtual environment. So the Mclean project heavily concentrated on an area inside the local town, and we did that so that the participants or users were familiar with the streets. So they had some idea of where they are, and they didn't have to be so concerned about navigating around the environment. So the build-up of the virtual environment mainly entails basically creating the geometry for the buildings. In this case, we took a map from Google Maps and we built our town from that. Just the Google Maps provided us with a good reference point of distances and sizes of buildings. And then we used the photos to model from there. So the initial alpha phase was just to deal with the geometry of the buildings. So you'll see in the picture on the right-hand side, we've just got the plain white buildings with the geometry, a bit of green grass and the roads. So simple coloring used. And then throughout the evaluation, the user had a predetermined path and they were guided through that path with some road signs. And along that path, we tested them for quite a few different measurements or driving performance measures, which included speed, their adherence to road rules, stopping at stop signs and giving way at roundabouts, etc. And then also reaction times, which was based on them reacting to a hazardous scenario. How quickly they saw the scenario and then how quickly they pressed the brake. And we did also capture throughout all development phases a user's heart rate data. So we used a little Fitbit watch. We grab that data as they're doing their virtual driving test, and then we can use that data to see how cool or calm and collected the driver is, or if they panic in a particular situation, which you will see a bit of a spike in the heart rate. So yeah, that was mainly the alpha evaluation, was just to build a proof of concept, get the car working, and then get some initial feedback from the users. So if we move on to the next slide. So the next slide was obviously the beta development release. And as you can see on the picture on the right-hand side, we started to improve the visual quality of the virtual scene. So you can see in this, we're starting to add textures, such as or what they call textures in virtual environment, which is, the materials on the building, brickwork, concrete, etc. like that. So that was of our own accord, that updating. And then for the feedback, we got a lot of feedback about the steering. So in the initial alpha release, we had no force feedback for the steering. We just used the steering wheel by itself. So there was no resistance when turning. And what nearly every user said, it just didn't feel natural. They couldn't control the car. They had a lot of challenges. So that was one of the big improvements. We went back, fitted a force feedback device, which gives some resistance and makes a natural feel of the steering. So for example, if you pull the steering wheel left and you let go, the steering wheel is going to try and come back to center, just as in a real vehicle that where the wheels are canted and do the same response. Also the braking and acceleration. So in the initial alpha release, the braking was just simply on and off due to a lack of sensor in the actual original vehicle. So we used an on-off switch, which was the brake light switch, and then we converted that into an actual switch that could determine the pedal's position, which then gave greater fidelity for the braking. And also the acceleration was improved. So in the process of building and developing virtual environments, we need to take into consideration physics. And so we're trying to mimic the physics of the road against the tires, and then the tires against the vehicle, and making sure that the vehicle rolls on hills, etc., has some inertia, but that the inertia is not too great so that they don't never stop, and that the inertia is not too little where they just let go of the accelerator and they come to a stop. So it's trying to fine tune that sweet spot. The next part was that we had a bit of feedback around in the alpha phase, we put them straight into a test. They didn't actually get to practice the driving simulator to get familiar with how it worked. So we actually produced some practice tracks. And in this case, we had a straight line, so they just basically got used to accelerating and braking. Then we had like an oval shape, like a Daytona racetrack, and that was to then start to get used to steering softly. And then we had a figure 8, which had some intersections in there, and that allowed them to really take hard turns and just to get familiar with the driving simulator and how it works. Yep, and then we just basically, so that was practice driving. We kept the driving test in the town, but we just changed a few aspects of that to make the drive a little bit more easy to follow for participants. And then the last one, and then obviously, just like the first one, the same results were printed and shared out to the users where they could see how they did through their driving performance tests, such as staying within the speed limit, their reaction times, etc. So if we go to the next slide. Okay, so we've come down to the last phase, the final development phase, and as you can see, the visual quality's improved again. So now we're adding trees, vegetation, trees, cars, signs, shop signs, etc., etc. So that was always part of the process, and then some of the feedback we got was to fine tune those same things, the steering, the braking, acceleration, and the car physics, so the suspension, etc. So just making sure that people felt comfortable and trying to align the virtual car to the real car. We removed the practice driving courses from the beta phase, and we replaced them with 3 driving test scenarios. So the first one was an open highway where they drove just straight down an open highway and just tried to stay within the speed limit. Then we had a country driving test which checked speed and did some reaction times as well. And then the final one, which was the town, which has been present throughout all the releases. We did testing for stopping at stop signs and roundabouts and use of indicators, etc. So those were the 3 phases that we came to realise were quite beneficial after the feedback through the alpha and beta phase. And again, the results were printed and shared with the users, including their heart rate, etc. But now they had 3 driving tests. So they had the open highway, the country, and the town instead of just 1 driving test. So they got 3 sets of results. And if we move on to the next slide. Okay, so this is an overview of the driving report. It actually didn't change throughout any of the development cycles. We got really good feedback on the initial alpha release for the presentation of the results, which was between a strong and strongly agree result on a scale. So we've kept it pretty much the same, but as you can see here on the right hand side, the results, we've got each of the driving test scenarios. So for this one's when they drive around the town, we test them in intersections, roundabouts, reaction and speed. So you'll see for the intersection and roundabouts, we're looking that they have correct use of the indicator, so that they're indicating at an appropriate distance from the intersection, and they're indicating on and off roundabouts. And you'll see in this one, they passed all the indication tests except for the last one, which they failed. They passed all the give way tests at the roundabouts. They failed to come to a complete stop at the first and third intersection, but they came to a complete stop at the second. You can see that the average reaction time for this user was around the 1 second mark, which seems to be a general average reaction time for an average driver, not for an elderly, but average in all. So they were still pretty good on the reaction time. And then they sped through 2 speeding zones, so the last one that they passed. And down the bottom, you can see their heart rate throughout the test. So you can see for this one, they start out fairly calm, and then they build up for that initial starting to use the simulator, and then they stayed at a sort of a constant heart rate. And that little tick at the end is probably when they're finished, take the headset off and come out the vehicle. So the next section I'd like to talk about is the approach to evaluation. So obviously we talked about the development cycles, the alpha, beta, and final release, and the whole action-based research. Now we're going into how we actually evaluated the system at each of those development cycles. So if we can go to the next slide. Okay, so this gives a good overview of the evaluation phases and what was conducted in each of those phases and the time it takes to do so. So you can see here, alpha moves to beta to final. Each of those evaluations we assigned about an hour and a half, which is about right. So for each participant, they go through a pre-questionnaire, and that pre-questionnaire was a lot longer for new participants because we got some background information about their current driver's license status, maybe some support they get for transport, and some questions about pension and where they reside, etc. And then returning visitors don't need to fill that information in again, obviously. So they do that pre-questionnaire, they test the simulator, and then they do a post-questionnaire. So the idea is we get their view before they use the simulator, and then we get their view after they use the simulator, and that helps us determine whether the development is meeting expectations or there's areas that we need to improve upon. And so after all those 3 evaluations phases, so after the final evaluations, we conducted a 1-hour focus group. And what that did was basically we got as many of the participants to come back, spend an hour. We looked at themes and topics. So we had everyone do a bit of a quick brainstorm and a round table for the different ideas to improve Hector VR. We then put them on big post notes around the room, and then at the end of the focus group, everyone gets a series of 3 stickers, and they can choose the themes that they thought would make the most significant improvement. So yeah, if we can move on to the next slide. Okay, so one of the important aspects of the survey was what they call a technology acceptance model. And what that means is you're looking at some important factors about the technology and how the users come to accept and use that technology. So what that entails is, as I've just shown, the pre and post surveys to determine a user's perceived ease of use, whether they see that the technology is useful, their attitude to using it. Are they going to use this technology in the future, or if not, why not? And whether they think it's of great value, and then obviously behavior, whether they intend to actually go and use it or not, whether they just see that it's a one-off use. So the Hector VR had some 8 TAM questions that were related around those themes. And the main thing here is that we want to get their perception before using the technology. Do they think it's easy to use? Do they think it's going to be useful? And then after their response after using the simulator, yes, it was easy to use. No, it wasn't as easy as I thought to use. And that just helps us look at the development that we're doing and whether we're meeting expectation. So if we can move on to the next slide. Okay, so this gives us a bit of a background of the numbers for each of the evaluation phases. So over the whole course of the 3 evaluation phases, we had a total of 63 individual participants, which is really quite high, especially for new technology such as this. Usually you would see maybe 15 to 20 users, but to their credit, it was quite amazing to see the elderly generation really wanting to participate and seeing their role as quite important throughout all the phases. And they had a really great time of coming back, and they were just robust and completely understanding where the technology was at. And yeah, they were just a dear pleasure to have, actually. They probably complained less than the more technology understanding youth. So it was a really good experience. So for the alpha evaluation, we actually had 28 participants. So 20 of those participants came from the Inverell region, and then we had a nice community bus drop off 8 participants from the Tamworth region, so that we had a different perspective, maybe from a different demographic. So for the beta evaluation, we had 29 participants in total. So we had 14 that returned from the alpha evaluation, and then we had 15 new participants. And we designed the evaluations to allow new participants to come in at any of these stages. And that was just to make it flexible, but it also gave us a bit of perspective and benchmark to compare new participants, but with new participants across all evaluation phases, and then also participants that had seen it and used it prior, they could give us feedback of where they thought it had improved. So we got both perspectives of new and returning participants. And then in the final evaluation, it consisted of 37 participants. So we had 17 that returned from either alpha or beta, or they've done both alpha and beta. And then we had 20 new participants in that final phase. So as mentioned before, the alpha and beta evaluations, they took about an hour and a half each. And so for those numbers, we conducted all evaluations over 1 week, but because the numbers increased a little bit in the last evaluation, we conducted that over a week and a half. And then the two focus groups were just conducted on one afternoon. So that was quite good, and that just involved participants both returning or new participants in their final evaluation to come along and just talk through those things. Okay, so we could probably move on to the next slide. Okay, so while we are coming back in June to do the results in more in depth, I thought I'd provide some demographics about our target audience for the evaluation. So here you can see we had participants aged between 64 and 92. So the 71 to 75 age bracket was the highest participation rate. So I think we had 16 participants in that one there. So our youngest participant was 64, and we had 2 elderly participants at 92. So they did a great job. It was, yeah, interesting to see. That definitely an inspiration to see 92-year-olds use your technology. And if we go to the next slide, this was the gender breakup. And what was actually quite interesting is that females represented a slightly higher participation rate for user evaluations. And that was consistent against just single evaluations, so someone that had come to alpha, beta, or theta, or those that did 2 or 3, the whole 3 evaluation phases. So you can see they basically doubled the participation rate for those that participated in 3 evaluations. But even in just 1 evaluation, they were nearly 15% higher. So that was really interesting to see, and probably went against what we initially thought was males wanting to play with technology more than females. It just broke that trend, I think. So that was really nice to see. If we go to the next slide. So yeah, this is just a quick summary. So Hector VR is a mixed reality driving simulator. So what that entails is we use a physical car, and using all the physical instruments, the steering, brake, accelerator, and shifter, and we combine that with the virtual reality. So in this case, we use the Oculus Rift headset. So they wear the Oculus Rift headset while in the physical vehicle, and they drive a virtual car around a virtual scene, so a town, etc. So Hector VR, as we've talked about today, was developed to assist older drivers by providing them some objective feedback, so those driving tests about their driving competency and driving performance. And a good reason for that is so that they can make informed decisions and dignified decisions about their license restrictions and relinquishment. So the hope is that they, so for instance, if their reaction time slowed down a lot, they might restrict themselves to driving on busy highways and just staying around the local town, or they may even choose to say, look, reaction time is not good enough. I might relinquish my license, which we hope they don't do if they're still driving well. But it just gives them the information to help them do so. So we use the action-based research approach, which is that iterative process of planning, acting, and reflecting. And then for the evaluations, we use TAM, which is looking at pre and post surveys, questionnaires, to see what does the simulator meet expectations. And we had a total of 63 participants, but aged between 64 and 92. So that's a really good rate. And then we'll be back sometime in June to present the actual findings of the results. So at the moment, just collating all the data and just looking at how best to present that as a body of research. And I believe that's it. I think we're open up for Q&A.
Thank you both for your presentation today. I encourage anyone that has a question to just place it in the question panel on the right-hand side. We do have a couple of questions coming through. First question is from Claire, and she asks, how do you both see the uptake of driverless vehicles or the impact on older drivers or projects such as this?
So I think AI vehicles or self-driving vehicles in themselves still probably, while the technology is here and they have the ability to, they're pretty close to being similar to a human driver in mistakes wise and errors, etc. I think we've probably still got a long way for that to become into realization and be on all public roads. So I don't think it's going away anytime soon, but obviously in the future, I do believe that maybe 30 to 40 years down the track, we might have roads that are completely autonomous. Until that time, there's going to be a very difficult scenario. One of the main challenges with AI vehicles is that if we could tomorrow change all the roads that everyone drove on to have AI vehicles, it would be a much easier task because we can control all the vehicles, they can talk to each other and be able to navigate themselves around. The problem that we have at the moment is that while trying to introduce the technology, we also have human drivers and they're less predictable to the AI vehicle. So, so in the meantime, while they haven't come about, I think that, yeah, road safety is important. So we want to help drivers here and now. And that's where the virtual reality comes in, so that they can practice and test their driving competency in a safe environment. I don't know if you've got anything to add, Sue?
No, only just that safety and allowing older drivers to practice in low-risk environments to improve safety is a fundamental factor and will be for the length of time before AI vehicles, driverless vehicles, are on the roads.
That's right, and it may actually help facilitate that transition as well. So you can imagine, I'm not too comfortable of me driving a vehicle and seeing another vehicle driving towards me with no driver. that might be a bit overwhelming. And so you can imagine that you could train people to see what to expect and help build confidence to overcome that initial phase. So it could be, you know, repurposed in that they're actually not driving the vehicle, they're sitting in and watching the vehicle being controlled autonomously, and then starting to be comfortable with that before they go on the real road. So yeah.
John has asked, how does the driving stimulus experience specifically help a person with dementia, or how have you seen any results so far in the project help someone with dementia stay on the road?
So I'll maybe just answer a couple of aspects of that question. I guess from the project's perspective, we didn't necessarily have people within the cohort that had a diagnosis of dementia that impacted on their capability to continue to drive. We did have some people within the trials that had a diagnosis of dementia, but it wasn't impacting their capability. So there's two aspects to that. If we're using virtual reality simulated driving for people with dementia, we are using it from the perspective for self-determination for those people. For the experience for people with dementia that are unable to have a license, it is a way for them to, I guess, remember or reminisce. But virtual reality has more of a place in other areas for people with dementia, such as immersing them in an environment that they are familiar with without any risk or pressure associated with that. It's more of a pleasurable experience. I think potentially people with significant dementia, driving a vehicle could prove frustrating for them.
Thank you. We have time for a couple more questions. I'll go to the first question. Does a person need to have any experience with technology, or did the participants within the project have experience with technology?
Good question.
Yeah.
Yeah, so yeah, I'll just quickly, the answer in essence is no, they don't need to have experience, and our experience was all about completely debunking the myth that older people don't engage with technology. They do, and very well.
I think that was proven as well throughout the project. Obviously, having the 63 participants is quite high, but majority of them had little to no experience with technology. They might, and those that did had experience with tablets, and so that was part of the reason for us to have that experience day, just so that they can have a go at VR and understand what it is before they use the driving simulator. But in saying that, the participants, new participants in final, or some of those in the beta phase, didn't come to that experience day. And yeah, they were just like any other user, to be honest. We get a lot of different users from a lot of different backgrounds and age groups come through our lab, and they acted just as a younger person would. So yeah, it was quite eye-opener.
And last question from Matt. Currently, the project is based in New South Wales. Do you have plans on making this nationwide?
So part of what we will do once we have finalised the prototype is look to other options to replicate the prototype and even improve on that. And we're currently looking at ways in which we can do that, because definitely there is a need for Hector out there in the wider world, and particularly in smaller rural communities where in New South Wales, for example, you have to, once you're over the age of 85, have a driving test with a specialist occupational therapist. So in the lead up to that, it's really important to be able to have that practice to improve your confidence. So around Australia, we see it as having application not only for older people, but also for people with disabilities, for younger people setting out to learn to drive, right through to a place in the transport industry in general. So our plan is to look for partners and look for other opportunities to further develop Hector.
Great, and I think that's all the time we have for questions. If you have any other questions, please do submit them via sat@communityresourcing.com.au, and we will pass them on to Sue and Michael in aims to get them answered as soon as possible. Thank you both for your time today and presenting this webinar. The YouTube link will be shared with all attendees after today's presentation and will be available on satcommunity.com.au. So what's next for the collaborative? The collaborative will be hosting a National Australia Roadshow with a range of innovation events next week featuring international researcher Professor Greg Alexander. These events will focus on the role technology can play in improving the quality of care within the community care and aged care sectors. On Monday, the 11th of March, we will be in Logan, and then on Tuesday, the 12th of March, we will be heading to the Sunshine Coast. On Wednesday, the 13th of March, we will be in Sydney before we head to Canberra on the 13th and 14th of March for further events. For more information on any of these events, please visit www.satcommunity.com.au. If you haven't already done so, please go online and register for the collaborative. You'll be able to access today's presentation and have the opportunity to ask further questions. Please check the collaborative for more information on upcoming events. If you have any further questions or inquiries, please email us at sat@communityresourcing.com.au. Once again, I would like to thank the members of the collaborative research team and today's guest speakers, Sue and Michael. Thank you everyone for attending today's session.